알아서 듣기 바랍니다. 네. 그래서 오늘은 좀 easy version. I will teach you easy version of the binomial tree version of Hohenly model. There is another continuous time version of Hohenly model which is actually easier, but I think this is easier to understand. Okay, Hohenly model. Okay, Hohenly model. So Blackman, we will learn Hohenly model and Blackman-Toy model. But Blackman-Toy model is such an exponential version of the Hohenly model. So that's very simple. So as for Hohenly model, this is Hohenly model. Very simple, right? So this is Hohenly. The Hohenly model is one of the simplest models that exactly fits the term structure of interest rate. So to go back to our slide, our Excel sheet, Google spreadsheet, I think this one. Okay. So this is our data. Of course, I will generate more data shortly, but this is our data. Let's say two-step model. So this is our data, and Hohenly model exactly fits this data. So exactly fits this yield curve. This is given. With given this yield curve, we generate bond price is zero coupon bond price and forward rate. But anyway, this is given data, and Hohenly model exactly fits this one. Of course, our previous risk neutral model also exactly fits the data, and Hohenly model is another one. The model is specified as follows. Let RIG be the continuously compounded interest rate in node J, step I. So step I, so this is, for example, this one is step 2, node 2. So it is, it's step 2, and from beginning it is 1. So it is R11. It is R21 model. It is R21. This part is R21. Okay. And then if Rij, suppose this one is given, the next one is generated, this one and this one. This one is generated by some sort of theta I multiplied by delta. In our model, delta is 6 months, 0.5, plus sigma square root of delta. Okay, so, and the risk neutral probability always 50%. Okay, and then like this one is given, this sigma part is given by the data. Okay, this part is given by the data. Delta is time. This is given in the previous period. Risk neutral probability is half given. And we have only one free parameter at each is this one. So in our previous model, we change risk neutral probability to match the data. But now, instead of fitting risk neutral probability, we will gonna fit this one. This change. This is different. So we will do optimization with this one. So risk neutral probability is given. So basically we will generate this one. We will generate risk interest number that is consistent with yield curve. So that is our goal. There is a lot of ways to make this interest model consistent with yield curve. There are a lot of ways. And another way to set even risk neutral probability 0.5, 50%. And Hohenly model is the easiest one. This is by far the easiest one. Okay? So that's why people use this one a lot. Then how can I then this is, let me delete this one, delete. And then let me duplicate this one, duplicate. And then let's change this one is to Hohenly model. So data is given, okay. And then, okay, this is given. So for interest model, okay. Now it move from here to here and from here to here. So basically we need two theta, right? We need theta 1 and theta 2, right? So there is a, let me change it, theta 1 and theta 2. And let's say theta 1, theta 2 is, how can I make theta 1, theta 2? Theta 1, theta 2, let me pick the initial value, okay, like 0.01, and 0.01. Okay. So this is just arbitrary value. Okay. And then we need interest rate volatility, which is this one. Let me use this one. We want to make it consistent with the textbook. So interest rate for so this is something you have to estimate, but it is not that difficult. You can collect interest rate for the past several years and calculate like standard deviation and just annualize it. That is fine. If you use the weekly data for interest rate, then you can calculate standard deviation of the interest rate process, and then you can multiply like a 52, something like that. Root of the 52, something like that, right? If you use daily data, then you can multiply daily data, and then you have daily data with interest rate, then you can calculate standard deviation, and you can simply multiply root of 250, something like that. So it is very easy. So this one is something you can calculate. So let's say this value is like this. Then we can generate interest rate model like this. From this one, okay, this one is, wait, theta 1. Let me change the order. 2. Okay, let me take this. Okay, so from this one, from moving to here, so it is going down. So we have to use this one, right? Okay, we have to use this one. So this is 1 is, this one is, this one plus, this one plus, so theta 0. No, it is a theta 0, okay? Theta 0, this is theta 1, okay? So from here, this one is, now it is not given from cut anymore. This one plus theta 0, okay, plus delta multiplied by delta. Okay, then we have this part. Okay, we have up to this part. But then it is going down, so we have to subtract this one and square root of this one. So then we have to subtract this one, interest rate volatility. Let's put this on, let's change this one and define president. Let me say this one 4. Let me change this one 4 because we will use this one 4. So minus 4 multiplied by delta square root 0.5. Okay. Okay, so we have this part, right? 1 point, am I right? And then no, it is yeah, anyway, yeah. So okay, you understand this part, right? And this one is now it is another negative of this one. So it starts with this one minus now. Actually, I can just copy and paste of this one. Okay. So then it is the now. Okay. This one plus now F7. Now you have to do F7. Now theta 1. The next stage is theta 1 multiplied by delta. Okay. Delta and 4 and then delta 0.5. So this one is based on previous one. I add theta delta, and then because it is going down, so minus 4 square root delta, right? This is easy, okay? Done. Any question until now? 여기까지 질문 있는 사람, 이거 굉장히 중요하니까 물어보는 거 빨리빨리 질문해야 돼. 질문 있는 사람. 원재 학생 질문 있나? 뭐 손을 들었던 것 같은데. 세타의 의미. So what does theta means? That is something we are gonna estimate. So theta is like predicted component, right? So in interest rate model, okay, that's actually a good question. Okay, so Rij in this model, Rij is given, and about we are interested in next period interest rate, right? Next period interest rate either can go up and go down. It can be either Ri plus 1j, which is going up, and Ri plus 1, J plus 1, it is going down. And then this theta multiplied by delta part is predicted part. So it is called the drift term. It is known part. So we have some information about the future by this amount, but still there is an uncertainty about the sigma part. So this part is something we have information possibly. Some predicted component. It is predictable part. So we move. Suppose we move interest rate Rij to this side, then it is difference of the interest, change of interest rate. Right? Change of interest rate, known part and unknown part. This is theta I multiplied by delta part is known part. The next part is unknown part, uncertainty. Yes, Dave.
The interest rate for they always use like historical volatility. They don't use like implied volatility, like interest rate options.
That's another interesting question. Okay, another interesting question. If we have option data, we can calculate sigma actually. But now it is a chicken and egg problem. Okay, now we have data. We want to calculate option price now. That is our goal. So we need sigma. But in some problem, option data is given, and we want to re-engineer sigma somehow. That is implied volatility. But anyway, at this point, our goal is to calculate derivative price. Okay, so we have to find some. Find some intuition about sigma, and there are other ways to get the sigma, like a lot of technology, a lot of the technical way to calculate sigma, but one easiest way is just historical data and get the standard deviation. That is one way. Actually, worst way, but yeah. There is another econometric. You will learn a lot of how to estimate sigma, something like that in the econometrics class, I think. Okay, that was a good question. Any other question? We will not have much time, but there are interest rate model called LMM, LIBOR market model, and HJM model, His-Zero Merton model. There are like that, and we have to find the sigma that exactly fit the data as well, but that is another story. In that case, we have to use forward rate, and then yeah, we would. That's very important, but we will not have time. But anyway, any other question? 또 질문 있어요? 이거 굉장히 중요하니까 스텝 바이 스텝으로 다 이해를 해야 돼요. 한양대학교 파이낸스 경영학과 나와서 호연리 모델을 모른다면 사람들이 이상하게 생각을 하겠지. 거기 이상민 교수님이 돼 있는데 어떻게 호연리 모델을 모를 수가 있냐? 그렇죠? 말이 안 됩니다, 여러분. 호연리 모델을 모르면 말이 안 되는 거예요. 파이낸스 경영학과 나온 거 맞아? 가짜 대학생 아니야? 뭐 이러지도 못해. 자, 또. 자, okay. I assume everyone understands this part. And then now we have to fill this part. Actually, this part is easy. Okay. Since we have this part, in order to get this, we can add this one 2 times, right? Okay, so we can simply add. Of course, I can generate from this one and going up. I can use this formula, right? I can use this one. But I can simply start from this one. That would be much easier. So for this one, I can use this one plus 2 multiplied by 4. Right? That sounds much easier, isn't it? Yeah. So I can start from bottom and add this one. So in order to move from here to here, I can add this one 2 times. Okay? This is much easier, right? So my interest rate model is done. Okay? And then from this interest model, my implied bond price would be look like this. Right? Hohenly model delta, and then yeah, this like this. 이게 B3와 같다고. Okay. And then because my risk neutral probability is always 0.5. Actually, it's not so necessary. So my bond price, okay, maturing 1 year, after 1 year it paid 100, so 6 months later looks like this one. So okay, this is correct. So this one, this particular rate is now risk neutral probably 0.5. So what I can do is exponential of minus of this one multiplied by delta discount one plus this one actually, and then plus this one divided by 2, right? Because I mean now risk neutral probability 0.5, so I can simply add them all divided by, because it's just average, right? Yeah. Now we have a pricing error of 1.93. So our model price is this one, but our data tells real price is this one. So pricing error is this one. So how we can change it is pricing error 0? Yes, exactly. We are gonna change this one to match this one exactly 0. And unfortunately, I can do this one in Google, so I have to download it in Excel. You have to know this one step by step because you are gonna do this homework with homework with R, with very long. I'll give forward yield like 10, something like this, and then you have to match it. But anyway, now I have the data and solver, and where is our target? So what is our target? which set? 여기서 뭐가 돼야 돼? 여기 타겟 목표 설정이 뭐야? pricing error. And then minimize. 변수 셀 변경. 어느 거? Which one should I change? 세타 0. Done. Okay? So first 세타 0, first component of Hohenly model 세타 0 is this one. So I make copy and paste and then this one. Done. This is 0. So exactly matches bond price. Now maturing 1 and 5th year, 1 and 5 year, 1.5. Then we can do this RP. We don't need it anymore. So this one we can say just we don't need on this anymore. So this one plus this one divided by 2. Okay, and then P7. This is this one. So okay, this is divided by 2. Okay, this one and this one is again. Now I think I can remove this one, and then I can remove this one divided by 2. Okay, so this one. So what is my, so still we have pricing error, this one. Well, by the way. 이럴 수가. 이걸 닫고 그러면. Okay, let me download it again. Okay, now how I can do the optimization, how I can make this one 0? 누가 나와서 해볼 사람? Any volunteer? So how can I make this one estimate 호연리 말은? Volunteer? 오늘 발표한 여연태 학생이 한번 와서 해보지. 와서 나와서 한번 해봐. 아니 그냥 와서 해봐. 설명 안 해도 돼. 와서 한번 해봐. Okay? So what would be the next step? 그러면 어떻게 하죠? 그래서? 데이터 그것도 좋은 방법인데. 근데 그거 말고 웬만하면 회찾기로 하지. 그런 어드밴스한 거 말이요. 그것도 뭐 괜찮은 방법이에요. 네. No. Wrong. Okay. Okay. Now you matched this one, but now we have a pricing error for this one. Okay. We want to make both of them 0. So how can you do that? 저 어떻게? You messed up something. Okay. 뭔가 또 다시 자신 있게 할 수 있다. 누가 좋을까? 누가 좋을까? 김기태 학생. 방금 여현태 학생이 맨스업 해가지고 할 게 2개가 됐는데 이제 해볼 수 있나? 한번 해봐. 오케이 와서 한번 해봐. 오케이. 이재용 학생. 예, JY가 한번 해보세요. 하나 됐고 very good. 이 아니라 왜 거기 아직까지 뭐가 왜 이러지 이거? 다시 뭔가 맞게 했는데 최소 해찾기 확인. 됐네. Good job. So now 이현태 학생 이제 알겠어요? 뭐가 문제였는지? 김기태 학생 알겠어? 뭐가 문제였는지? 한 번만 더 설명해줘. 설명을 해봐 와서. 나 한번 설명해봐. 중요한 거니까 스텝 바이 스텝. 뭐 어쨌든 설명해봐. 우리말로 설명해도 되고. So Dave, do you understand what is going on?
Actually, I don't understand Korean.
Oh yes, that's the problem. 뭐 영어로 설명해줘야 되겠네. So you have this Excel file, right? So 네. 그럼 우리말로라도 설명을. 그 설명해봐요. 여현태 학생이 뭘 잘못했냐. Now let's assume that suppose interest volatility changes to something like this, then we have pricing error is not so big. But anyway, I don't want to repeat this. So is it okay, right? So is it cool? So now we can calculate. So we have implied risk rate tree, Hohenly model implied interest rate process that exactly fits this is called, which means that exactly fitting means that there is no error. Okay, no error. Pricing error is 0. That exactly matches the bond price, which means there is no error. So it exactly fits the data. Now, since we have interest rate model and risk neutral probability always have, so it means we can calculate interest rate dynamics, interest rate derivative. So suppose there is a Ford contract, so that let's assume that now in the Ford interest rate is now 2.5%, 2.5%. Let's assume that 2.5%. In this case, then when interest rate is this one, it pays. So this Ford contract matures in 6 months later. So when Ford rate is interest rate, this one we receive this one. We receive this one minus this Ford rate multiplied by $1 million. So we receive this one. But since the Ford rate is this one, but interest rate go down, now we have to pay. We have to pay, which means that this one minus this one. So at the 6 months later, in this Ford rate contract, we will pay this one. When interest rate, we will receive this one when interest rate is 3.75. We'll have to pay this one when interest is 3.5. So the present value of this Ford contract now simple. We can discount. We can calculate average of the future. Now it is risk neutral probability 0.5. So we can simply calculate average. We can calculate average of this one, okay, and then discount it. So we don't need actually RMP anymore. Okay. Anyway, the answer is the same because I match everything 0.5. So we can simply calculate average, right? Yeah, but still anyway it is the same. So we can calculate interest derivative, and we can calculate bond put option similarly. And if there is a crazy derivative, like we can calculate this, and then this one in this case it is a Ford contract or swap is just one. Swap contract is basically a series of the Ford contracts, so it doesn't matter. So in this case, swap rate is 4%. Now it's maturing 1 year later. So 1 year later, depending on this, wait again. So in this case, swap rate is 4%. So now in this case, let's assume they will receive fixed. Suppose we receive fixed, then now, okay, now we receive fixed. Let's assume that we receive fixed, which means we have to pay floating. So which means that we receive this one, 4%, F4. But now we have to floating rate, which is this one. Okay. So per dollar we lose this one, and let's say notional amount is $1 million. $1 million, and then this one, and then I can just move around. So if swap rate is 4%, then since I receive, okay, I have to pay now floating, receive fixed. So in this case, when interest rate is 6%, I have to pay because it's greater than 4%. But in this case, because I receive fixed and floating rate is all below 4%, now I receive money. And then from here on, I can calculate now risk neutral probabilities or 0.5 anyway. So I can calculate average of these two and discount it. So average is with discount rate is this one. From this point now calculate average of this one and now discount rate is this one. So we'll calculate the value of this subcontract. Okay. Now of course we can calculate arrow-Debreu securities as well. Right? In case of arrow-Debreu securities, right? Arrow-Debreu securities, we can start from 1, and then now what we can do is simply now risk neutral probability this one. So what we can do is exactly same. So risk neutral probability always 0.5. So 0.5 multiplied by, okay, now this one, and then discounted with minus this one. Okay, actually, let me start from this one. So for this one, what we can do is, now it can move from here to here or here to here. So first, we can do is this one multiplied by exp of minus, now interest rate at this point is particularly this one, multiplied by delta. Okay, delta, and then we have P7, 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 P8. 헷갈린다. 네. And then another one is plus. Now we have the pass from below. So now 39. And then interest rate, now we have to use this one. So over here, so P8. Okay, and then we have to divide it by 2. Right? Because risk neutral probability or 0.50%, so we can divide by 2. Right? So other thing is same. Right? Oh, no. This is 1. So this is erodible securities. So again, given the erodible securities, so this is erodible securities generated with Hohenly model. Okay, and then this using this erodible security, now we can calculate like this path dependent derivative like this one, right? 10 to minus 10, 5, 90, something like this. Okay, so it is very path dependent, very theoretical. But now, since we know error value of erodible securities, which pays $1 for particular situation, so we can just multiply pay up and erodible securities for this particular state, and then sum them all. Then we have price of path dependent one, even path any arbitrary derivative depending on following this tree. Any question? This is exciting, isn't it? 재미없어요? 한 명만 더 해볼까? Okay. And then suppose we have a different interest rate tree. 잠깐 이거 다 옮겨놓고 이걸 다. 내 생각에 이상민 교수님 또 이렇게 친절하게 설명 안 해주실지도 몰라. 내가 착해서 이렇게 친절하게 설명해 주는 거고. 네? 엄청 친절하신데 또 이제 본인 모델이니까 이렇게 친절하게 안 해줄지도 몰라요. 이상민 교수 너무나 머리가 좋으셔서 또 여러분 이 정도는 다 알겠죠. 아무렇게나 이렇게 설명하실지도 몰라요. 어쨌든 좀 내가 데이터를 한번 바꿔볼까? Now suppose that interest rate volatility went down. So let's say this is the minus. Now it is a quantitative easing, so price this is still is almost 0. 아 이제 지로가 안 나오네. 됐어. Okay, so now interest because of quantitative easing and everyone want to lower interest rate, so there is no interest rate volatility or between zero. So in this situation, our question is actually more exciting case would be actually I want to increase. Okay, volatility a lot. Okay. Now, okay, we have huge pricing error. So now let's assume that in the future, so anyway, this interest rate, although we use past data for interest volatility, what matters is basically we have to put our estimation on the future volatility. So there is a slight illogical inconsistency here. We want to know future interest volatility, but we don't have any future data. So we have no other way but to use past data. But anyway, let's assume that we expect a lot of interest volatility in future because of quantitative easing and Brexit, and then uncertainty in China and uncertainty in European market and everywhere geopolitical risk, blah, blah, blah. So let's assume that there is a lot of interest volatility, huge interest rate volatility. So now we have to match Ho-Lee model again. Actually, that's what is going on. Ho-Lee model should be updated instantly. Okay? Whenever we have a new data about yield, this yield curve change every day, every moment. And the interest volatility possibly change every moment. But anyway, let's assume that the yield curve data is given, but because of huge uncertainty in the future, let's assume the future interest rate goes up, and now we have this pricing error again. So how we can match this model again? Any volunteer? 장슬기 학생이 나와서 한번 해보세요, 이번에. Okay? 아, 잠깐만. 거기서는 이제 그렇지. 그거를 숫자를 0.2를 0. 뭐 그 정도 해. 더 높여서 한 0.3 정도로 해 보지. 0.3. Okay? Now we have a pricing error, so how we can do that? Good. Now it is too easy, isn't it? Very good, thank you. Okay, now I assume everyone perfectly understands our Ho-Lee model. You are now all Ho-Lee model expert. Therefore, I can comfortably give you homework. Okay. Implement Ho-Lee model with R. Use the example here. Google spreadsheet. Right now, you can do optimization, right? You calculate internal rate of return, so you know how to do optimizations. And here you have to use R for the optimization. And then due date is 이거 닫고. 아까 어딨지? 내가 실수로 닫아버렸나? 숫자를 좀 바꿔놓고 싶은데. 재미없나? 이거 진짜 재밌는 건데. 재밌어. Ho-Lee 모델 생각보다 어렵지 않죠? By the way, I want to point out one disadvantage. I dare to criticize Professor 이상빈 교수님. But anyway, there is a drawback in the Ho-Lee model. If you take a look at the now interest model, there is clearly drawback here, right? Interest rate is negative in some cases. That's very bad, right? In ordinary economy, interest rate cannot be negative, right? So if interest rate is negative, it means that if you put your money in the bank, you receive negative interest rate, so which means bank take away your money. Then why you bother to put your money in the bank? You can simply put your money in your house, unless you have huge amount of money, right? So negative interest rate, it can happen, but it is not quite realistic. But in Ho-Lee model, interest rate can become negative. Actually, almost always there is some part of interest rate that is negative. Almost always. That's a drawback. So next class we will learn Black-Doman-Toy model, BDT model, in which case there is interest rate cannot become negative. It is always positive. Okay. It is easy to make interest rate positive. All we can do is we can simply take exponential of this one. Then it's always positive, right? So in the BDT model, what we do is instead of fitting interest rate directly, we fit log of the interest rate. and take expectation. That's the idea of BDT model. Then we have always a positive exchange. We have always a positive rate. Okay. Now it is all positive. So please use this data. Yes. And then what would be the proper due date? Due is the and the due date is any suggestion? Next Friday, 15. Okay. No, that's too long. 13. Okay. May and then before class start. Good. Any question about today's topic? Yes, Richard. Yes, it is, but we have class. Yeah. And it is birthday of Hanyang University, but we don't care, okay? So we have class on the next Wednesday. 네, 개교 기념일. 그래도 우린 수업합니다. 예비군 훈련? 그럼 어쩔 수 없네. How many of you go to reserve army? That's 얘 진짜 맞아 이거? 막 오현정 학생 손든 거 아니야 혹시? Okay. There's about me. There we have a military national security issue over here, so I cannot help on delay. Okay, then we have to adjust student presentation. So 15, okay? Okay, so 김영훈. 또 예비군 훈련. Reserved Army Training. Okay. So 김영훈 학생, you do the presentation on 13th. 김영훈 학생 어디 있지? 네? 화장실 가서 금세 사라졌네. 그 13일에 하라고 오면 좀 알려주세요. Then I have to change the due date, so yeah, 15th then. No, the 13th, so it is fine. Okay. No, I was slightly confused. So yeah, it doesn't affect. 그렇지. 이 인터레스트 레이트 모드를 찾아서 프린아웃을 해야 이걸 제너레이트하는. So for your homework, expected output is this part, of course. Basically, especially this one. This is a key output, and then actually this one and arrow blue securities too. So in your output, in your model, the final output, your output of your R code is theta and arrow blue securities. Let me write down. Just a moment. Yeah. That's in. Yes.
Like the difference between arrow, navla, and the number one is direction. Because that way you test arrow and
Arrow double securities is the once you have this interest rate model, you can calculate this arrow double securities. So once you have arrow double security, you can do the derivative pricing using this one or this one. But for path dependent securities, you have to use arrow double securities for this particular case.
so homework would be get the interest rate and then arrow.
So homework, because if you have this theta, you can generate interest rate model directly, right? Because they are all dependent on this. This is given. So in your homework, you have to generate this theta 1, theta 0, theta 0 and theta 1. And then this one. That would be enough. Any other question? This is the output of your code, okay? So in your original estimation, it possibly starts from like 0.2 or 0.0.3. So you have to put arbitrary, like internal rate of return. It is like some value you have to calculate. For internal rate of return, you have to put your initial guess in the beginning, right? Or in your homework, you have to put out your initial guess. And then from that initial guess, the model runs, the R optimized runs, and then generate this one. 네? 무슨 말인지 알겠지? Okay, any other question? Okay, thank you. And then see you next week.